Today it's a pleasure to introduce to you Professor Semir Zeki, who is Professor of Neuroaesthetics in University College London. And many of you may ask, well, what is that word neuroaesthetics? Never heard of that before. He was previously Professor of Neurobiology, which is a more familiar term, I think, in UCL. The Wikipedia definition of neuroaesthetics: it's the use of neuroscience to explain and understand the aesthetic experiences, that's things like music and beauty and wonder, at the neurological level. Professor Zeki is Fellow of the Royal Society and the Academy of Medical Sciences, and is a foreign member of the American Philosophical Society, so plenty of accolades to his name. He's been primarily interested in studying the organization of the primate visual brain and the areas that are responsible for experiencing different aspects of the visual world and things like beauty and form. He's written a number of books, including amongst those A Vision of the Brain, Inner Vision and Exploration of Art in the Brain, and Splendors and Miseries of the Brain. And it's a pleasure to welcome him today, and he's going to talk to us on the neurobiology of beauty and its implications.
Thank you. Thank you, Chairman. Thank you all for coming. I appreciate it. I am a neuroscientist, neurobiologist, in fact, and I've spent most of my time using anatomical and physiological methods for studying the brain. So when I started looking at beauty, there were some eyebrows raised and some criticism. Fortunately, these criticisms were tucked away in safe places like the New York Review of Books and things like that. The criticism is this, and it's worth looking at it briefly. It says that neurobiology can never address the question of beauty. Well, you see, it's wasted on me, because neurobiology does not pretend to address that question. It has never said it will address this question. Neurobiology is interested only in the neural mechanisms that are engaged when you experience beauty, or when you experience hate or love or desire, which is as legitimate a scientific question as asking what are the neural mechanisms that are engaged when you experience color, a topic to which I have devoted a considerable amount of my time. So that it is a mechanism for studying and understanding the organization of the brain. And what more interesting topic can there be for understanding the experience of something that most of humans seek for: love and desire and beauty. Most of us seek it, and most of us spend considerable fortunes on trying to attain it without necessarily doing so. Now, I take heart from the fact that it was a philosopher who defined beauty, because in pursuing this topic we have to rely on philosophers and historians of art, because they've been thinking about it for so long, so their insights are important to us. And one of the important ones, one of the most famous definitions of beauty, is Edmund Burke's, the Anglo-Irish politician and philosopher. The beauty is for the greater part some quality in bodies acting mechanically upon the human mind by the intervention of the senses. Now, if you look at that definition, you'd find that 2/3 of it is actually about the human brain, because the mind is, it may not be the same thing as the brain, but at least a considerable part of the mind is enabled by brain activity. And the senses are, of course, entirely the nervous system. So as early on, when people started considering the question of beauty, they admitted the importance. This is not me. Oh, what? Is somebody else? Oh, is it there? Okay. They admitted that the brain is important. Now, when we attack the question of what are the neural mechanisms that are engaged when we experience beauty, we need a question to ask. Beauty is a vast subject. So the question was very, very well framed for us by Clive Bell, the husband of Vanessa Bell from the Bloomsbury Group. He wrote a book, which is a very good book, sadly not as well known today as it ought to be, published in 1914. He said, if you can tell me what is common to all objects that arouse the aesthetic emotion, then you have solved the problem of aesthetics. But the historians of art and philosophers of aesthetics have never given an answer to that question, so we thought we would try to give it, but only in a neurobiological context. So he said, let me see if I can get this. What is common to the Hagia Sophia in Istanbul and the windows at Chartres Cathedral and Mexican sculpture? This is his list. Chinese bowl, Persian carpet, the frescoes of Giotto at Padua, and the masterpieces of Poussin, Piero della Francesca, and Cézanne. This is his list. And his list, you will notice, is entirely visual, which is not good enough for us because we want to go beyond and say, is there anything common to everything that is experienced as beautiful? Music, moral beauty, mathematics. And so we expanded the study to include, in the beginning, music. Now, I want to tell you, the other thing is that we do not conflate some totally ignorant man in Scotland, a Scotsman. He wrote that there's a difference between art and beauty. We know that. We know that. We excluded art historians and artists and everybody else from these studies because we don't want to conflate art and beauty. And we know that the art and beauty were seriously separated when Marcel Duchamp sent a urinal to an exhibition in New York, which he called the Fountain, and threatened to sue the curators if they did not exhibit it. So we know all of that. We know all of that. So what we wanted to do was to take subjects who were ignorant, that is, not historians of art, not artists, not painters, not musicians, and ask them to listen to music, to look at paintings, and each one decides for themselves what they find beautiful. Now this brings us to the third point, that whenever you talk, I don't know, many of you remember in the 1960s, whenever anyone gave a talk, somebody would get up and say, what about the workers? But whenever you talk about beauty, somebody says, what about culture and learning? So we got people from all races and backgrounds, but excluded people who were knowledgeable. Indeed, Clive Bell himself said, if you want to talk about beauty, which he did conflate with art, never talk to an art historian because he knows too much. So just ordinary people, because they are capable of experiencing beauty. And what you do is you show them paintings and get them to listen to musical excerpts. They rate them and bring them back and put them in the scanner, show them these paintings and musical excerpts again in the scanner. They re-rate them, and you can then determine where the activity in their brain occurs. And the principle behind that is like this, that cells in parts of the brain which are very active, their metabolic requirement increases, so more blood is channeled to that area, and the scanners detect the difference between oxygenated and deoxygenated blood and can refer that to a particular part of the brain. So that is basically the principle on which the functional magnetic resonance imaging works. Let me just show you some of the stimuli which most people found beautiful and some of the stimuli which most people found ugly. So this list by Ang was qualified by most, but not all participants as beautiful, whereas this one by Lucien Freud, which is the benefits supervisor taking a nap, was qualified as very ugly. Now, you can see that this is a painting which is worth many millions of pounds. It's got great painterly qualities. It projects questions of decay and decadence and passage of time. But the point is that it was not perceived as beautiful for the people who were taking part in the experiment, and that's the only thing we're interested in. For music, all of them, without question, we had people from China and Japan and India and of course Britain and Western Europe. All of them qualify this next piece from Mahler's Fifth Symphony as beautiful. This is a 16-second excerpt. Now, and all of them thought this was ugly. the second violin concerto from Ligeti. Now again, a musician may find great musical qualities in this, but it was not perceived as beautiful by the participants. That's the only thing we were interested in, the experience of beauty by individuals. So what you do then is they go into the scanner, and once you get all the results in, you, irrespective of what each one found beautiful, you make a contrast of all the brain activities when the experience was of beauty versus not beautiful, right? So individual differences get ironed out, and you get the answer about the experience of beauty alone. Now, the first thing is that when people look at at paintings, the activity is in the visual cortex at the back here. When they listen to music, the activity is in the auditory cortex. But when you ask them, when you look at the parts of the brain which were active when they were experiencing beauty in paintings, you find that in addition to these visual areas, there is an area here which is part of the emotional reward center of the brain, medial orbital frontal cortex, which becomes active. And when you look at musical beauty, when you look at the areas which are in which activity correlates with the experience of musical beauty, activity in the same place. So in fact, there is this same area of the medial orbital frontal cortex which is involved, which activity in which correlates with the experience of beauty, whether derived from visual or musical sources. This is quite important because it gives teeth to the, if you read Locke or Hume or Plato or Schopenhauer or Kant, they don't specifically talk about beauty of paintings or beauty of vases. They talk about beauty. They talk about beauty of theater, poetry, music, everything. So there's an abstract element to their discussions of beauty. And in fact, in terms of the brain, there appears to be one area which is always active, irrespective of what the source of the visual or musical beauty is. Now, some of you may have been following the press recently about this fierce debate about what is acceptable as statistically significant, because the change in activity in the brain, which is detected by changes in blood flow, is really about, if you get 12% change, you're doing quite well. So you've got to employ statistics of a fairly rigid character. I don't think that these apply to this because it's been repeated so many times in so many different laboratories now that I don't think the question of statistical significance is very important anymore. So this is then the area of the brain which is active when you experience visual and musical beauty. And if you look at the activity there, you find you are able to answer a question which has been central to philosophies of aesthetics, namely, but which they have not answered. Can judgments of beauty ever be quantified? And the answer is yes, because if you look at the activity here with visual beauty, then the activity is higher for things, for paintings judged as beautiful than for those judged as indifferent or not beautiful, and the same is true of musical beauty. So, let me just summarize. The question that Clive Bell asked was, if you can tell me what all things which are experienced as beautiful, what he said, which arouse the aesthetic emotion, have in common, you have solved the problem of aesthetics. They never did. What we have done, we can say to you, all things which are perceived as beautiful, they have as a correlate activity in the medial orbital frontal cortex. Right? The second question is, can you ever quantify this? And the answer is yes. The experience is directly related to the activity there. So the higher the declared experience of beauty, the greater the blood flow there. Right? So essentially, we have made of the study of beauty, the science of beauty, something quantitative, localizable, and therefore now the objection that anyone may have evaporates, because you see, up to about 1980, it was common to say, well, these are subjective experiences, you cannot study them because science is objective. But now this is very objective. Okay, so now if you look at, I'm just going to give you a few more examples, show you that experience of all beauty correlates with activity there. Now you can look at stimuli which are joyful and those which are sorrowful. The Three Graces by Canova is an example of a joyful beauty, and the Pietà of Michelangelo is sorrowful beauty. They again correlate with activity in the same part here in the medial frontal cortex. And the Greeks had a single word, kalon, to denote both moral beauty and physical beauty. Now, physical beauty correlates with activity in the medial orbitofrontal cortex, and moral beauty does too. And these are studies which are quite interesting, done in the United States, not by us, in which subjects are asked the questions such as, you are very hungry, and you have the option of having a very good steak, or giving it up to a hungry Syrian child. What will you choose? And the first one is you satiate yourself. The second one is morally more beautiful. And that activity correlates, again, with the activity in the medial orbitofrontal cortex. Now, you know and I know that people who are very good-looking and beautiful have got every advantage always in interviews, in everything. People are born with silver spoons. But you know and I know also that very often that is very deceptive, because they may turn out to be of very poor moral character. And the reason for this conflation, and this is pure speculation, I think, is that I think we know that both types of activity correlate with activity in the same part of the brain, and therefore we confuse, there is a risk of confusing moral beauty with physical beauty. But it does raise very interesting questions which people are beginning to address. To what extent is moral beauty inherited? To what extent is it specified burden? To what extent is it something which you acquire from your environment? So this is just to show you this activity there with attractiveness and with goodness rating, moral rating. See, again, it is quantitatively related. Now, we go to, so far, we have been talking about sensory beauty, moral beauty too, but we have been talking about it in a way in which it was not dependent upon culture or learning. So, because this question, what about culture and learning, I thought it wise to go to the extreme example of the experience of beauty that's dependent upon culture and learning. And what would that be? That would be mathematics. So the question was to get an idea of which parts of the brain are active when you experience mathematical beauty. Now, you can't pick up people in the streets at night and ask them to look at equations and tell you whether they're mathematically beautiful, which you can do with visual and musical beauty. So you've got to get mathematicians. But before you do that, you've got to be nice to mathematicians and ask them to produce some equations. And I did not, they're very difficult people, mathematicians. And I never realized that they have such bad temper. I mean, you see, as we got these equations together, there was one mathematician who would object that this has too much physics in it, and this one has got too much geometry in it. They want pure mathematics. So this experiment, which I'm going to describe to you, took 6 years in the making because of the difficulty. And what's more, these are all the revelations for me. Mathematicians are also extremely emotional people. They come out of the scanner in tears. I think this is so beautiful. So you get 60 equations, and you get 21 subjects to look at mathematicians, postdoc or PhDs, and you get them to look at these mathematical, to study them actually at home, rate them, and then come back and look at them in the scanner. That's when they start crying, when they see the very beautiful mathematical equations. And they re-rate them in the scanner, and again you detect the blood flow in the brain when they have categorized something as beautiful and something as ugly. Now, the equation which was characterized by most people as, in fact, probably all as beautiful, is Euler's identity equation, which Michael Atiyah, who was a colleague of mine in this paper, describes. Now, wait for it. He says it's the mathematical equivalent of the soliloquy from Hamlet by Shakespeare. That's how. So it is considered by many mathematicians, perhaps not all, to be the most beautiful equation ever written. Right? The one which most people qualified as ugly is this one, which is Srinivasa Ramanujan, who was, of course, a brilliant mathematician whom Hardy brought to Cambridge and who made his fame in Cambridge. And it is the equation which expresses the inverse value of pi as an infinite sum. Now, some mathematicians have written to me quite angry. Now, you come out here and we'll teach you a lesson. This is a beautiful equation. You come. But you see, it is not me. The important thing is that the mathematicians in the scanner at that time did not consider this to be beautiful. That's all I'm interested in. I'm interested in their experience of beauty. And so from this it follows, too, that the results of these experiments really have validity for the time they're done. It is possible that a mathematician looking at this equation of Ramanujan for 10 years might find it very beautiful. Indeed, some mathematicians do. But this is not important because the mathematicians in the scanner did not find it beautiful. So where is the activity now occurring? And if you look at the brain slices, you find, well, it occurs in the same identical place as the experience of musical, visual, and moral beauty. Right? Now, somebody, by the way, please do not think that this is the only area which is active when they see mathematical equations. No, there is no mathematical beauty spot in the brain. No, but this is the area which is active along with other areas, but this area is active when they experience the beauty of mathematical equations, but also when they experience beauty derived from other sources. Now, somebody wrote to me, a mathematician, wrote to me saying, well, isn't that to be expected? So what's the big deal? No, sir. It was not to be expected. It could have been anywhere. It could have been in the areas which are devoted to numbers. It could have been areas which are devoted to formulating, calculating in the brain. Nobody would have expected that it would be here. But this result is the most robust result of all the beauty studies that we have done. And it was the most thoroughly reviewed paper I have ever published in my life. About which I would like to say something, which I realize that a lecture is not a place to vent your prejudices, but I shall. Now, I sent this paper to Nature because I thought it would be quite interesting, and they sent it back within 24 hours, saying this is not interesting. So I said, oh dear. I'll send it to Science. And Science did the same thing. They sent it back without reviewing it. So I thought, look, I cut my losses. I'll send it somewhere where they're more hospitable, Frontiers in Human Neuroscience. It was the most thorough review that I've ever had, as I say. And since its publication in February of 2014, it has been viewed 146,000 times, which is a record for any paper in neurobiology, and probably more than a record for any paper ever published in Nature throughout its history. And it shows you one thing. It shows you one thing, that in spite of all the hype and their impact factors and this and that, there is one deficiency that these people have, which is that they cannot judge what is of scientific interest. Because this paper has been viewed by people in Syria, by people in Iran, by people in Iraq, by people in Jammu Kashmir, by people in Libya, not to mention all the other countries. So in war-torn countries. So let us just forget about the ability of these people I make no comment about their ability to judge the scientific validity of a paper, but certainly their ability to judge the scientific interest of a paper is defective. Now, having got that out of the way, let me talk about a bit more about mathematical beauty. Mathematical beauty, as I said, is the most extreme example of beauty which is dependent upon culture and learning, because you cannot appreciate mathematical beauty unless you have the culture of mathematics. But is this statement really true? The answer is no. Because whether you are a mathematician, let me say, which is at Cambridge, Cambridge prides itself to be the biggest mathematical place, or in Tokyo, or in South Africa, or in Brazil, or in Iceland, as long as you understand the language of mathematics, you can appreciate the beauty of mathematical formulations. And by the way, our mathematicians were drawn from different cultural backgrounds. So the question is, what does mathematical beauty consist of? This is the question that Immanuel Kant raised. And he said, well, the mathematical beauty consists simply of saying, this makes sense. Well, he stopped short there. You see, he did not take the next step. The next step is, it makes sense to what? And to whom? And I say that it makes sense to the logical deductive system of the brain. And because the logical deductive system of the brain in all of us is the same, that is the reason why we can appreciate mathematical beauty. Now, there is an irony here, because mathematicians who are difficult people say that the formula must have no exceptions. No exceptions. If it's got an exception, then it's no longer beautiful, no longer anything. It's not mathematics. But actually, how many people see it? How many people? I mean, of all them, maybe 200 people say there's no exception to this. Right? Much more interesting is that there is no exception to the logical deductive system of the brain throughout humanity. It's all the same, and so all of them can agree that the mathematical equation is very beautiful. Let us look briefly at the history of the beauty in mathematics. The theory of relativity of Albert Einstein, published in 1915, 1916, the special and the general theory of relativity, was in fact not very well understood when first published. I have read accounts that the Nobel Committee did not understand at all. That's why they never gave him the Nobel Prize for relativity. But it was accepted for one reason, because of the extreme beauty of its mathematical formulations. So, Paul Dirac, English physicist, wrote in 1933, and I quote him almost verbatim, but not quite. He said, the theory of relativity imported beauty into mathematics to an unprecedented degree. Before that, the guide to the truthfulness of a mathematical equation was its simplicity. But since the theory of relativity, when you have to choose between simplicity and beauty, you must always choose its beauty as a guide to the truthfulness of the mathematical equation. And here your mind goes back to the Philebus of Plato, where he said that mathematical beauty is the highest form of beauty because it gives you an idea of the structure of the universe. And in a way, when you talk to a physicist, and I know some physicists around here who might challenge me, very often they reach their conclusions because the equations that they are working on make sense and because they are beautiful, and they reject others because they jar. And then they are capable of apprehending truths before they are even experimented upon. For example, the theory of relativity is one example. Only last week was it they gave the Nobel Prize for gravitational waves, was the theory of relativity predicted a century ago. And black holes and dark energy and all of these other brilliant mathematical formulations are actually, at least in part, the result of equations which make sense and are beautiful. So it turns out that we can now defy the philosophers who laughed and said, what can neurobiologists say about what beauty is? Well, we can say a little, not much, but we can say a little. We can discuss the uses of beauty. We can, in fact, say that it goes beyond the Darwinian descent of man, that it is used for sexual selection, which of course it is, but this is not the sole use. Another one of its uses is giving you insight into the structure of the universe through mathematical formulations. And indeed, for Plato, mathematical beauty was the highest form of beauty just because of that. Now, towards the beginning of the last century, there was a very brilliant Swiss-American mathematician. Well, he was Swiss and became American later for obvious reasons, who said, Hermann Weyl, his name, who said, all my life I try to combine truth with beauty in my work. But if I have to choose between the two, I always choose beauty. Well, he worked for many years on a formula to reconcile the electromagnetism of James Clerk Maxwell with the theory of relativity of Einstein, and came up with a formula which he thought was very beautiful, and sent it to a journal to be published, and they sent it to Einstein for review. And Einstein said, you can't publish this. This is against all the known facts. You know, Einstein did not believe in quantum mechanics, at least not at the beginning. So they rejected it, sent it back to Hermann Weyl, and he wrote back to the editor saying, well, it may be against all the known facts, but it is beautiful, so publish it. And the editor, being a wise man, not like the present crowd we have there, said, all right, I will publish it with an appendix giving the objections of Einstein. And Hermann Weyl said, fine, let's do it that way. So it was published, and 10 years after publication, with the advent of quantum mechanics, the formulations of Hermann Weyl were found to be all correct, and the paper, I gather, is now republished, but without the objections of Einstein, which it should be for historical reasons. So you can see that beauty has got uses which go beyond being a path to sexual selection, beyond just giving you pleasure. It has practical uses every day in laboratories of mathematics and physics, and in guiding people towards a truthful equation which solves partly some problem in the universe. And it is really quite important to realize that this is due to one fact, and one fact alone, which is that we all have the same logical deductive systems in our brains, no matter where we're born, no matter what we have, which university we're educated at. As long as we learn the language of mathematics, we can then appreciate the beauty. Now, Bertrand Russell said mathematics rightly possesses not only truth but supreme beauty, thereby separating truth from beauty. And Hermann Weyl said, when I have to choose between truth and beauty, I always choose beauty, thereby separating truth from beauty. Perhaps the man who had the right answer was John Keats, who said, truth is beauty, beauty, truth. That's all you know and all you need to know. Thank you very much. I left you plenty of time.
Thank you very much. I'm tempted to say that was beautiful. And you've left plenty of time for us to ask questions. Who would like to?
I removed about 7 slides just before, 4 minutes before, because I think, one message is enough.
Thank you. There's a question down there. There's a microphone will come round. Steph, there's one down the front here.
First of all, in regard to the Euler relation, the equation that you mentioned, Werner Heisenberg is on record as having said, only 2 things in this world makes him think of beauty. That one, and the Medici Chapel in Florence.
Really?
Now, I don't know whether you'd agree with that, but I thought I'd make that point. Now, I'd like to ask a question. Up until 1980, you couldn't give this lecture because of functional magnetic resonance.
Yes.
Right?
Yes.
You know, you were lost. You couldn't
Yes.
really attack the nature of where the centers in the brain, the activities occurred.
Yes.
Now, there's a finite resolution in all microscopic imaging.
Yes.
My question is, can one foresee, and you need somebody like the experts. I mean, I wish Adrian Dixon was here, who was the head of radiology in Cambridge, but he's lecturing in Egypt today. But he would be able to answer this question. There may come a day when you have 10 times or maybe 1,000 times as great a resolution as you now have.
Mm-hmm.
And then, under those circumstances, you might find that mathematical beauty is in a separate compartment from, shall we say, artistic beauty or musical beauty. Oh, you can't answer that question, but I have to make the point.
Well, you assume I can't answer it. Well, you are absolutely right. The resolution is poor. The resolution, the temporal resolution of fMRI is extremely weak, but it can be supplemented with magnetoencephalography, which is a ghastly method. It's very complicated to use because the amount of the signal-to-noise ratio is very low. But they are developing, very, very powerful machines. Now, at the moment, there is a 7 Tesla fMRI machine. However, I personally would not wish to have my son and daughter go into those. It's too powerful a magnetic field. But I have not the slightest doubt, that in the coming 20 years, there will be machines developed which would have a resolution of, say, let us be generous, say, 50 microns. That is the diameter, twice the diameter of some cortical cells. Now, if you look at the primary visual cortex of humans, you get a good tracing of the history. First of all, people thought there was no primary visual cortex. Half the posterior part of the brain was visual. Then they found the primary visual cortex. Then they found it had a special architecture. And in the 1980s, they could subdivide into small, tiny compartments of 100 microns, which differed in their architecture. It is entirely possible that mathematical beauty correlates with activity with a special group of cells. What is equally likely is that the activity. Say, let's suppose you've got a group of cells here. These cells are not living in void, they're connected. It is the iterative activity between the two that's important, which is different from that with musical beauty, which may have a different kind of thing. What I'm trying to say is, and thank you for saying I could not have given this talk before 1980, is that mathematical beauty belongs to the biological category of beauty. Biological category. You see, if you take, so I can study the brain very nicely with it. If you take, say, architectural beauty, now forget it, because you can't. The Japanese is probably going to find the Japanese Buddhist monasteries more beautiful than churches, and the Christians are going to find these are more beautiful than mosques, and so on, or cars. But with mathematical beauty, it doesn't matter, because it is entirely rooted in biology. And mathematicians have not realized that they are biologists.
The single blood cell, I've forgotten how to be precise, you could see it under the optical microscope. But, these days, you can look at the individual molecules of hemoglobin in the blood cell, and it may well be that you mentioned the transfer of oxyhemoglobin and the ordinary hemoglobin. It may well be that in a temporal way you can distinguish between even different types of mathematical.
Well, yes, but I want, may I tell you something, may I, Mr. Chairman, something to, if you look at macro perception, so what you perceive 100 milliseconds, 100 milliseconds after the stimulus appear, you have the experience that everybody has. The color of my tie is tied to my tie. You can tell the shape, you can tell the color all at the same time, and the position and space. If you do the same experiment at periods of less than 100 milliseconds, you see the color 80 milliseconds before you see the form. So you've got micro perception there, which is not predictable from macro perception, just as quantum mechanics and particle physics is not predictable from gravitational physics.
There's a hand right at the back. Let's try that one. Go from one part of the room to another one.
You say you only used ignorant subjects for the music and art beauty. Have you compared or considered comparing that to art historians and musicians and see whether their perception of beauty is sort of changed by that?
Correction, I did not say I used ignorant subjects. I said
Sorry.
In fact, quite the contrary. I did not use art historians and artists because they know too much. A big difference. No, I have not done that experiment, and I'll tell you why. I think that probably other people are pursuing that experiment. I did not do it because I'm actually, my main scientific interest lies in what is universal, common to all humans. And so I want to get away from the particulars. And by the way, unless you understand what is common to all humans, you will never understand how they handle particulars.
I'll go across just a couple there, and then we'll come down to the front, and then there's some in the middle as well. We've got enough time, I think.
You've referred to the two senses of sight and hearing.
Mm-hmm.
I'm intrigued to know whether beauty can be perceived through touch, taste and smell. I think, for example, of a blind person. They won't appreciate a painting
Yes.
visually. Can they appreciate it in other ways, or can we use other senses to appreciate beauty?
Well, I mean, it is. I'm sorry, I don't have the reference on me, but there is a study which shows that the experience of gustatory beauty does correlate with activity in the same part of the brain. Touch has not been studied, actually, to my knowledge, and nor has smell. Smell, for obvious reasons, is a bit difficult to localize, but touch, obviously, my prediction is that when they come to study, they'll find activity in the same part of the brain.
Thank you. We'll come right down to the front. And then work backwards.
I've always been interested in the question, if we are looking at a painting, and we're looking at a painting that we deem to be authentic, and all of a sudden it is realized that it is a forgery, why do we view it so differently? And I was actually interested in the brain, the neuroscience, and I looked at some studies that were made at Oxford by art historian Martin Kemp and Andrew Parker, and they found out that actually the different parts of the brain were activated in a different manner, whether you're looking at something that you perceive as authentic as opposed to something that you perceive as forgery.
Yes.
And my question is, do these various activities of the brain lead to our different emotion vis-a-vis the painting, or is it the emotions that lead to different activities in the brain?
You're being very difficult.
No, I guess it's something that really makes me rather curious about it.
You know, I also don't know the answer to that question. I mean, I have, for reasons I have avoided all these situations where context is important. But, you know, the problem is, if you look at, if you ask this question, what you have to do is to use the technique of magnetoencephalography. That gives you, that's got a temporal resolution of 1 millisecond, all right? And then you can tell whether emotion comes first or whether the viewing comes first. But it is really awfully difficult to do.
There's a hand in there with the blue.
Thank you very much. That was absolutely brilliant. I'm a physicist by training, but art was my best subject at school. So in fact, I now paint pictures. So I've got a real interest in both sides.
Did I tell any lies?
Sorry?
Did I tell any lies?
Sorry. So I didn't hear the...
I said, did I tell any lies?
Oh, I never tell any lies at all. But the thing I was interested in that when you're trying to convey something artistically, especially if it's in an illustrative form, there's a distinct difference between curved shapes and things which are soft and beautiful, and you tend to associate those with beauty, and harder shapes like handsome, for example, tends not to be in the same category. I just wondered if the pictures you used actually found any difference between handsome and beautiful. But,
well, no, we did not distinguish between those. We used, you see, we were trying, these were initial studies, we were trying to see what everything that's perceived as beautiful. But you see, I mean, if you look at what is reputedly the most perfect rendering of the human body, of which I showed you one example, which is the Westmacott Youth, which is at the British Museum. Now, according to the authorities on the subject, the Greek sculptors used actually formulae for this, mathematical formulae. And you would be surprised. Do you know where you would find the largest number of articles on the golden ratio? Would you like to hazard a guess? It's in journals of maxillofacial surgery.
oh, right.
Because this is very important for them to get all the proportions, everything right, and there are mathematical which actually apply. Now you see, the question of symmetry in beauty, in fact, applies to the human body, but people then mistake that to say that symmetry applies everywhere where there is beauty. Well, there is no symmetry in the cathedral at Chartres, and there is no symmetry in the creations of Frank Gehry. But in the human body there is. So human body then again belongs to biological beauty, just like mathematical beauty.
Thank you.
Can I ask a burning
Yes,
question? You've looked for universals. Are
Yes.
there exceptions to those universals? So do people, the brain is plastic. Can we train ourselves to be better equipped to experiencing beauty? And are there those who have damage to those areas of the brains? Do they have less of an experience of beauty?
Yes. Well, I think if I may just talk briefly about that in a negative sense, there is no exception at all that I know of to the rule that somebody who is considered to be beautiful must have the eyes, the nose, and the mouth and the ears in exact relations to each other. Now, who is a man who made millions out of what he said, I want to give a visual shock? Any offers? Francis Bacon. Francis Bacon. He said, in his words, I want to give a visual shock. And he said, I give you a visual shock not by reference to the intellect, I do it through by my feeling. Every single painting of Francis Bacon, with no exception, because I've really written about Francis Bacon, is got a deformed or mutilated face and body. But look carefully and you find that the objects are not mutilated. The chairs, the couches, the tables, the windows are all intact. So he mutilated biological beauty, right? And this is a universal. This is a universal. So the second point is that I think it's fair to say that in spite of the race effect, and these studies have been done, there's a mild race effect, that people tend to have a mild preference. It's not big, but it's statistically significant. Mild preference for people of their own race. But a woman or a man who is considered to be very beautiful in Japan is very likely to be considered very beautiful in Europe. And that is the basis of the success of the catwalk. I mean, you know, the big fashion houses import models from all parts of the world. And they, of course, choose beautiful women because their business is making money out of beauty. Now, so if you look at biological beauty, say the beauty of faces or beauty of bodies, the variance there is quite constrained. It's limited. Nobody's going to find somebody with one eye here and one eye here beautiful. It's not going to happen. If you look at colors, right, so if you, without using language, if you take somebody from every nation in the world and ask them to look at a patch of color which is reflecting X, Y, and Z amount of long, middle, and short wave light, and ask them to match it with a chips, the variance will be even narrower. They're both biological factors. If you then ask the same people to rate architectural things, the variance goes like that.
Thank you. A couple of questions in the middle there, and then I'll go right to the back.
I just wondered if your work has any overlap with evolutionary aesthetics, that works on the premise that beauty is preferred, which is actually enhancing the race and promoting survival. So people would have a preference for paintings with water and landscapes with water and land, or in human beauty would be the criteria would be fertility, for example.
Yes, I mean, I don't know much about landscapes, and certainly beauty, but probably, I mean, anthropomorphically, I think it's perhaps best not call it beauty, but I mean, ducks and drakes, and they do enhance themselves with all sorts of things. Now, on the question of fertility, it actually is not quite as straightforward as that. I mean, men, when they are looking for women in a serious way, do not really look for the most beautiful women. They look at women who are curvaceous. There's some hint of fertility. And women do not go for the Tom Cruise type. They go for those who've got good rosy cheeks and look like they could be good providers. Which does not mean say they go for ugly people, but there are certain biological hints which are important to them. And this is not my work. It's fairly well known, published in all sorts of places.
Thank you. One further along, and then I'll go to Dennis running the back.
Thank you very much for your talk. You're talking about equations and things like that and mathematics. Greatly enhanced my understanding of Alexander Solzhenitsyn's Nobel Prize lecture. I presume you've read it, have you?
His Nobel Prize lecture, no, I read August 1914.
It's called One Word of Truth. And the main message is that art and beauty can change the world, because art can defeat the lie on which violence rests. Though when I took him, and he saw that from the perspective that the true artist seeks to portray the truth of God's created order in whatever medium, therefore true art is always dangerous to evil. But when I took him to speak at Eton College, he did venture to say that much of what passes for art today would not be regarded as dangerous by the KGB. And I would like to know what your comment is with regard to art and truth, beauty and evil. You mentioned lie at one point, so I thought it was rather interesting.
Well, this is a very, very difficult question. First of all, I have worked on hate. Hate is the source of evil. But biologically, hate is amoral. In other words, hate is a biological quality that we have. And it has been used for the survival of the species. Well, you kill the neighbors. You notice if you look at the current situation, for example, you find that much of the hate is directed by neighbor against neighbor. I'll tell you an interesting story. I was invited to Toronto to give a lecture on hate because I published, and they said, we're going to give you a business class ticket. And I said, I'll come. However, you must understand that the message that you will hear from me is not the message that you want to hear. Because he wants, this is the guy who wanted to sort of eradicate hate and say how we must love each other. And when I told him this, they wrote back saying, well, we're looking forward, but we can only give you an economy class ticket. Now, I think the question of truth in art, you know, the Velázquez portrait of Juan de Perea, which Lord Radnor and the nation allowed shamefully to be exported to the United States in 1974. When that was first exhibited in Rome, the critics said, all the this is the truth. All the other paintings are mere paintings. It spoke out, you know, very forcibly. It was very, very. Do you know the Juan de Perea by Velázquez? Well, I'll show you a slide. I've got one slide of it here. I think that there is ultimately the sort of a truth that we perceive in paintings. And that, I think, is why some paintings survive and others do not. I do think that they do speak to the truth. But it is, it is obvious, and I've now read this week that language did not develop 100,000 years ago, but 2 million years ago. Well, the visual brain developed 2 billion years ago. And so it's often, I mean, I can describe for you in 10 volumes the Pietà of Michelangelo, but 2 seconds exposure would give you an idea of it, much better idea of it. And there is something authentic. There is a truthfulness to it. I mean, I don't want to mention names because I don't want to down any artists, but I mean, there are some artists who are just not as good as others. And I think the difference lies in the truth that they convey. And what is interesting is that this truth can actually be perceived even by people who are not very knowledgeable.
Thank you. I think this probably have to be the last question. So,
by the way, because even by people who are not very knowledgeable, because our visual brains are the same, just like the mathematical brains are the same.
This very quick technical question, just out of curiosity. I can imagine that the people that you're getting, your cohorts for study, probably have never been in a MRI machine before, and it's noisy and somewhat constrained and constricted. I just wonder, how do you technically, how do you tackle in experiments habituation of people to that environment, and then you're also presenting them with a picture of Mona Lisa or whatever it might be? How does that work? Can you just talk us through a little bit how the experiment works? Thank you.
First of all, you exclude people like me who feel claustrophobic in these machines. Secondly, what you do is you have a signal that changes in size, and they have to report that. So they are attending. If they fail to report it, then you stop it. They are no longer attending. You see, there's a continual signal which is changing in the center of the screen. So it does not appear with every stimulus, but it appears regularly, but randomly. And they have got to press a button to say that they have the cross has changed in size. Now, we did have, give you an interesting example. Does that answer your question?
Well, not quite. I mean,
No.
it's very noisy. Some people are habituated to noisy and small claustrophobic environments more than others. And I just wondered did they have to go through several cycles where they would, just blanks, controls,
Oh, yes,
and then they would see the picture in front of them? Is that right?
Yes, it's repeated several times. Yes, absolutely, absolutely. I mean, I suppose each experiment would take about 20 to 25 minutes. So, and each presentation of each slide would be 3 seconds. So it's repeated quite often. And we did have a banker who said he was passionately in love with his girlfriend. Could he absolutely take part in this experiment? So he brought a picture of his girlfriend and 5 other girls of the same age, etc., and put him in a scanner, and he was snoring within 5 minutes. So, so he was excluded. But these are the controls that we have: blank slides, report changes, and repetition.
Thank you. At that point, time has flown. Those of you watching the clock will know that time really is flying in here, as the minute hand goes round at the same pace as the second hand. But time has flown. We've always said that we'll finish these by 2 o'clock. This has been a most fascinating lecture. Thank you very much. And I will say it has been beautiful. Would you join me in thanking you?